Okay, so let's talk about a powerful idea in math called composition of functions. Suppose we have two functions f and g. Okay, so now we can create a new function by plugging one into the other. This is called compositions. So we write f a small dot g x, and this means we take f as a function of g of x. So first we apply g to x and then we apply f to the results. So imagine you are going through two machines. The machine G takes the input x, the machine G takes the input x, and it gives you an output. So what does machine F does? So machine F then takes that output and gives you a final results. So it's like you're feeding x into g and then feeding gx into f of x. So let's try some examples, then you will see this idea clearly. So let's start with these examples. Here you're given two functions and you're asked to find the compositions of these functions. So let's start with the first one. So this says you have to find the composition of f and g. So by the definition, if you have something like this, you can write f of g of x. So what I'm going to do is, once I have a composition like this, I'm going to start with the definition of composition. So this means you have to evaluate f at g of x. So first of all, when I am evaluating this, I am going to replace inside function. So here you have to evaluate f at g. So g is given over here. So instead of gx, I'm going to write gx squared plus 3 here. I'm going to replace gx by this function. And then I have to evaluate f at this. So I know f at x is x plus 1. Whatever this function, you have to add a 1 in order to get my f. So in order to get f of this, what you have to do is you write that the function inside as it is and then you add a 1. Then you have to simplify after this. So here, first of all, you have to remove these parentheses. So you can remove the parentheses. It's because you have 1 outside of this parentheses. So it's going to be x squared plus 3 plus 1. And then you are going to combine alike terms. You have only 1 x squared. You're going to write it as it is. And then you add these two terms. It's going to be 4. So the composition of f and g is this function. Okay, moving forward, now let's look at the composition of g and f. Previously, we were talking about the composition of f and g. So there's a difference between these two. This is the composition of f and g, and this is composition of g and f. Okay, to get the composition, again, I'm going to use the definition. So you have to evaluate g at f. So previously we evaluated f at g. There's a difference. Okay, so now the first step is to replace my f of x. I know my f of x is x plus 1. So here I replaced my f of x, that is x plus 1. Now let's evaluate g at x plus 1. So I know that by the definition, g of x is square of this input plus 3. So to get this function, what I do is I square this expression and I add 3. So that is what I have done here. And then you have to simplify this expression. So first of all, you have to square x plus 1 and then you have to add 3. So to square x plus 1, what you can do is you can use distribution law. It's just x multiplied by x, you get a x squared, x plus 1, you get a x, 1 plus x, you get a x, 1 plus 1, you get a 1. So if you combine these terms, you'll get 2x plus 1. So that is exactly what I have here. And then you have to add a 3. Then you'll get x squared plus 2x plus 4. So this is the composition of g and f. So you can see there's a difference between these two functions. This is the composition of f and g, and it is x squared plus 4. Here the composition of g and f, it is different function. So now you have to evaluate the composition of g and f at -1. It's really simple. You have to take this function and you have to substitute -1 into this x. So here I have done the calculation. I took the composition and I substitute -1 and I got 3. Okay, now let's take a look at another example. So here my f of x is square root x and g of x is x squared plus 9. So first of all, let's get the composition of f and g. So here I wrote my definition. So here you have f evaluated at g of x. So then I replaced my g of x with x squared plus 9. That's what I have done here. And then you have to use the definition of f, because here you have to evaluate f at x squared plus 9. So f of x is square root x, which means you have to get the square of the input. So here this is the input over here. So you have to take the square of that function, which will give you this expression. And you are going to stop at this point because you cannot simplify this further. And now let's move into G, the composition between G and F. So this is the composition between G and F. So here again, this is the definition of the composition function. You have to evaluate G at f of x. So usually the order stays as it is. So you write the G and the inner function is going to be f of x. And then f of x is going to be replaced by this function. So now you have to evaluate G at square root x. So usually the g of x is x squared plus 9. To get g of square root x, you get your input and you square it and you add a 9. So once you simplify this, you'll get x plus 9. So this is the composition between g and f. Next, let's try to do the next example. So here you have f of x as x cubed and g of x as 1 over x plus 1. You have to get the composition. Let's start with f, the composition between f and g. By the definition, the composition between f and g is f evaluated at g of x. Next, you have to replace g of x by this function, which is this, and then you have to evaluate f at this input. So usually the f of x is x, the input to the power 3. So here I put my input and I have taken the exponent as 3. So I'm going to leave this in this step because I'm not going to simplify this further. Next, let's do the composition between g and f. So by the definition, you have to get the g at f of x. So instead of f of x, I'm going to replace x cubed. And then you have to evaluate g at x cubed. So g of x is 1 over x plus 1. So instead of x, I'm going to replace x cubed. So this x is going to be x to the power 3. So this is the composition of g and f.